All right, welcome. Today we're doing something a little different. The 5-minute SQL challenge. You think you're a pro with SQL? Well, let's put that to the test. You've probably written tons of queries, maybe even managed whole databases. But how well do you know the fundamentals when you're on the spot? Let's find out. No pressure, but the clock starts now.
Okay, here we go. Round one is all about the essentials. We'll start with a quick warm-up just to get the blood flowing. Ready?
So first, let's just state the obvious. SQL, or Structured Query Language. It's the language we use to talk to our relational databases. It's how we ask questions and get answers from our data. Simple enough, right? Okay, let's get into the real questions. All right, first question, and it's a classic. A primary key and a unique key. They both make sure your data is unique, but there's one absolutely critical difference. What is it? Think about how they handle those pesky missing values. And there it is. The big deal is nulls. A primary key absolutely cannot, under any circumstances, be null. It has to have a value. A unique key, on the other hand, is a little more forgiving. It can have one, and only one, null value in the column. That's the difference you gotta remember. Moving right along, SQL isn't just one big blob of commands, right? It's actually broken down into different sub-languages. Can you name the 4 main types? And here they are. You've got DDL, Data Definition Language. Think of this as the architect drawing the blueprints for your tables. Then there's DML, Data Manipulation Language. This is the construction crew actually putting data in, changing it, and taking it out. After that is DCL, Data Control Language. That's your security guard deciding who gets the keys. And finally, TCL, Transaction Control Language, making sure that a bunch of changes all succeed together or they all fail together. All right, let's get practical. You're looking at a table and you need to get rid of some data. You've got 3 tools in your toolbox: delete, truncate, and drop. They're all powerful, and they can all be pretty dangerous. So how do you know which one to pick for the job? Let's break it down. You use delete when you need a scalpel. You're removing specific rows and you might want to hit the undo button with a rollback. You use truncate when you want a really fast way to wipe all the data from a table, but you can't undo it. And drop? Well, drop is the nuclear option. It doesn't just delete the data, it completely vaporizes the table itself. Gone forever. So yeah, use that one carefully. Ah, this old chestnut. If you've ever interviewed for a data job, you have probably gotten this question: where and having. They both filter stuff, right? But they do it at totally different times. So what's the fundamental difference? And this is the whole story right here. It's all about timing. The where clause jumps in and filters individual rows before any of the grouping happens. The having clause, on the other hand, waits until after group by has done its job and created those summary groups. So, simply put, where is for rows, having is for groups. And just like that, round 1 is done. Feeling good? Warmed up? I hope so, because it's time to level up for round 2. We're about to get into some key functions now. Kicking off this round with a 2-parter. So you're sticking the results of 2 queries together. One of these operators is super clean and tidy, and the other one is way faster but kind of messy. Which one is which? It really all comes down to performance. Union is meticulous. It goes through every single row to find and remove any duplicates. That extra work makes it slower. Union all, on the other hand, doesn't care. It just slams the 2 result sets together, duplicates and all, which makes it way, way faster. So the takeaway is, unless you absolutely have to get rid of duplicates, Union all is usually your friend, especially with big data sets. So before we hit the next question, let's just quickly talk about a super important concept: the subquery. It sounds complicated, but it's really just a query that's nested inside of another query. It is one of the most powerful tools you have for writing really flexible and smart SQL. Anyone who's worked with real data knows it's messy. Null values are just a fact of life. So how do you actually deal with them? What are 2 common ways you'd handle nulls in your queries? Here are 2 of the most popular ways. First, you can just filter them out completely. You just add is null or is not null to your where clause. Easy. Or if you need to replace the null with something else, like a 0 or NA, the COALESCE function is your best friend. It just goes down a list you give it and picks the very first thing that isn't null. Super handy. Okay, deep breath. You've made it this far. Now it's time for the final round, where we put all that theory into practice. It's time to solve some actual code puzzles. This is the final boss. Good luck.
All right, here we go. This is a classic SQL interview question, a real rite of passage. You've got an employee table, and you need to find the second highest salary. Not the first, the second. Take a second. Think about how you'd build that query.
And here's one of the most clever ways to do it, using a subquery. It's kind of brilliant in its simplicity. See, the inner query, the one in parentheses, finds the absolute highest salary. Then the outer query just says, okay, now find me the highest salary from the group of salaries that are less than that absolute max. And boom, that gives you the second highest. And now for the grand finale. This is probably one of the trickiest problems you'll run into. You've got a table and it's full of duplicate rows. Your mission, should you choose to accept it, is to get rid of all the duplicates, but leave just one single original copy of each record behind. How in the world do you do that? So you solve this with a really neat trick using something called a common table expression, or a CTE. Think of it as a temporary little table you create on the fly. So step 1, we use the row underscore number function to assign a unique number to every row, 1, 2, 3, and so on. Now, here's the magic in step 2. We use partition by and tell it to group the rows based on the columns that define a duplicate. This makes the numbering restart for each new group of identical records. So the first original record gets a 1, the first duplicate gets a 2, the next gets a 3. Then for the final step, it's super simple. We just delete all the rows where our new row number is greater than 1. That leaves only the originals behind. It's pretty slick.
And that's a wrap. The challenge is over. So how'd you do? Did you breeze through the basics? Did those code puzzles make you sweat a little? Hey, either way, you just spent the last few minutes sharpening one of the most important skills in the entire tech world. That's a win.
You know, at the end of the day, SQL isn't really about remembering commands. It's about being curious. It's the language we use to ask really interesting questions of our data. You just proved you've got the tools. So I guess the only real question left is, what amazing questions are you going to ask next?